Good morning, Algebra 2. It is Monday, December 14th, which, as Luke said, is only 11 days till Christmas. So try to keep your grade up so that your parents don't take all your presents back to the store or Amazon, whatever it happens to be. Okay, so some of you on your quizzes, you need some help on that, and so you should come in tomorrow to get help on that, just as a suggestion. Okay, so today what I'm going to do is I'm going to go through example 1, 2, 3, and 4. And everything here is about complex numbers. And it isn't hard, it's just new and a little bit different. So the first example is with graphing complex numbers. A complex number is where you have a real number with an imaginary number. So in the form it's called a plus bi. Sorry, that's a little sloppy. This is called a complex number because it has both a real number and an imaginary number in the same expression. Okay, so what we're going to do is I'm going to take and graph these four so you can kind of see what goes on. And when you do yours, just make one graph and then put each of those on, but put a letter or a number next to it so you know what it is. So the x-axis in the complex numbers, this is the real numbers, is your x-axis, and your y-axis are your imaginary numbers. So imaginary are going up and down. So if I want to graph negative 2 plus 3i, I would start at the origin like always. I go to negative 2 on the real, and then I would go up 3i. I put a dot right there, and so that would be letter A. The next one's 5 minus 4i, so I have 1, 2, 3, 4, 5. I guess that'd be right there. And then I drop 4i, and so that would come down here, and that would be B. 3 plus 0i, that means I'd go to 3. 0i means you wouldn't go up or down, you just stay right there, and so right there would be letter C. And 2i means that they're not going to write it, but there really is a 0 there. So that means you start at 0, and you add 2i, which would be right on the imaginary axis, and that would be where your letter D is. So I think that's pretty simple. It's just weird because we've never done anything like that before. Okay, example 2 is for absolute value of complex numbers. And so absolute value of a complex number, a plus bi, is defined to be a squared plus b squared. And it's really just using Pythagorean theorem again, the square root of that. So there is an example of the book you can look at if you want to see that farther. I'm just going to go ahead and do the calculations. So this is your A and this is your B. So in this problem, the 4 is your A and the 2 is your B. And so what you would do is you would go 4 and you'd have to square it, and then minus 2 and you'd have to square it. Now I'm thinking it's plus, so this really should be, this is kind of weird, but be plus a negative 2 squared, and put these in parentheses. And so 4 squared is 16, negative 2 squared is plus 4, and so you end up with 20. All right, but don't worry about the I. If you see this, the I doesn't show up over here inside your square root. This one, the A would be negative 1/2, so it would be negative 1/2 squared, plus, there isn't anything with an I, so it would be plus 0 squared. And so negative 1/2 times negative 1/2 is 1/4, and you're done. For this one, there's no real number, so it'd be 0 squared plus 5 squared, and that would give you 25. All right, so those are just examples of how to do absolute value. Example 3 up here is when you're adding or subtracting complex numbers. Now this one, basically you're just going to add the real ones together and the imaginary numbers together. You do them separately. So if I look at this one, the only real number I have is negative 3, so I'm just going to write it down. And then I'm going to add a positive 5i and a negative 6i. And if I add those two together, that gives me negative 1i. You don't have to write the 1 if you don't want to. Okay, for number 2, the first thing you have to do is distribute the negative to both of these before you're allowed to add them. So it would be 2i minus 3 minus 5i. That's kind of tricky. If you do that in your head, you can make a simple mistake and get that wrong. So be careful. So again, the only real number right here is negative 3. And 2i minus 5i gives you negative 3i. And that would be your answer. For this one, you see they put the minus sign again in front of this, and so the first thing I need to do is rewrite this as 4 plus 3i. So that stayed the same. Distribute the negative to both of these. So it'd be minus 4 minus 3i. So 4 and the negative 4 would give me 0. And plus 3i and a negative 3i would give me 0. And so the answer to that one would just be 0. That's all it gives me. Okay, and the last one's example 4. And that is where you're going to add on a graph. This is kind of strange, but it makes sense once you do it. So what you do is when you add, you're going to do is you're going to graph the 3 plus 4i. So I'm going to go over 3 and up 4i. So that would put me right about there. And the other one's 1 minus 3i. So I'd go over 1 and down 3i. And then here's what's weird, okay? You have to start at your origin and connect this one. Start at your origin and connect this one. And then you have to make a parallelogram. So a parallelogram is going to go up like this and come down like this. And this is the point you want. Now to me it looks like it's over 4 and up about 2. So it looks like it's this. But to double check this to see if my graph is right, I'm going to go over here. What's 3 plus 1 is 4, so that's part is right. What's 4i plus negative 3i? It's only I. And so I realized that my picture's off a little bit and that my point should have been right here instead. And so this should be 4 plus I. So when you show your work on this last one, you need to make your graph, you need to make your parallelogram, but double check your work and just add these together like we just learned up here, so that you make sure you put your parallelogram in the right place. And that's it. That's all I'm going to give you. That's half of that page. And again, I think this is easier than the stuff we've been doing. And hopefully you'll find it easy too. All right, have a great Monday. And again, tutoring is tomorrow. If you need some help, 11:45 to 12:45, come in and get help. Thanks. Have a great day.